Okay, so in this video I wanted to do question 1 from MA 268 Algebra 3's week 1 non-assessed homework assignment. So this is basically for people who are revising. We were recommended to do these questions, all of them, even though that would just probably take me forever. So I'll try to do some of them, and then as a walkthrough or something like that. The ones I find easy, because otherwise it would take too long. Okay, so the first question is find the inverse of 11 modulo 101. Okay, so the way we're going to do this is, first of all, the only way this is possible is if 11 and 101 are coprime. Otherwise, if you think about it, for example, in like clock arithmetic or something like that, if you have 3, right, and if you add 3 to itself over and over and over again, you're going to get to 0 eventually, right? And then when you go around, you go to 0, and so you won't go around more than once. So all you'll get are the bigger numbers than 3, less than 12, right? I don't know if that really makes sense, but that kind of explains why it has to, that for example 3, the reason it goes up to 12 and goes to 0 is because 3 divides 12. So we want, first of all, not just dividing, because even if it didn't divide 12, for example 9, that would go around a few times around the clock. If you get 18, which is 6, and then around, you always get multiples of 3, right? Because 9 and 12, they share a factor of 3, and so you only get numbers that are multiples of 3. Okay, so in this case we want to show that 11 and 101 don't share any factors that are coprime, and we're going to do this using the Euclidean algorithm, which is exactly what they kind of ask you to do. So we're going to do 101 minus 9 times 11 equals 2. As the first step, we do 101 and then 11, and then we do the first step of the Euclidean algorithm. Now we take 11, then 5 times 2, and this is equal to 1. So we have that 101 and 11 are coprime by Euclid's algorithm. Okay, now what we're going to do is, because we want to find an inverse, I mean we've already got an 11 here, we've got a 1 here, and what we want is something times 11 to make 1. A good idea would be to take both of these modulo 101. Okay, so that gets rid of this, right? And so the reason we did this is now we know what 2 is modulo 101. It's minus 9 times 11. So we can substitute it into here, right? And so what we get is 11 minus 5 times minus 9 times 11. This is equal to 1 modulo 101. Okay, so that's what we get from the Euclidean algorithm. And now what we can do, 9 times 5 is 45, and then, well, we can just do this as minus 5 and we're adding it. That usually is easier. So we have 45 plus there's 1 at the front, over here, and then we have 1 plus 45 times 11, which you factor out, equals 1 mod 101. And so this is 46 times 11 equals 1 mod 101. I don't need to keep writing the 1, but whatever. So we have that the inverse of 11 mod 101 is 46, and so we're done. This is, we answered the question. Alright, if that makes sense. See you in the next one.